that we can think of any whole number as a decimal. This means that we can use our process for decimal division to divide one whole number by another and get a decimal result. Why is this useful? Because in particular, we can use this technique as an alternate means of rewriting a fraction, any fraction, in decimal notation. So just as a simple example, let's consider the fraction 2/5. Noting that 5 has more 5s as prime factors than it does 2's. One way to rewrite this in decimal notation is to multiply the numerator and denominator both by 2. We'll get 4/10. Since this is a decimal fraction, we can write that as 0.4. How else could we have found that? We could also have found that by understanding 2/5 to mean 2 divided by 5. Notice 5 is the divisor here. When I write a division bracket, I will write the 5 outside. Remember when we were doing whole number division, this was particularly boring. It was just 0 remainder 2. But now, if we understand 2 as 2 wholes, that is 2 point, write the decimal point in our answer above the decimal point in our dividend. Well, we see that 5 goes into 2 not at all. But we can add a 0 to the right of the decimal point. Notice, this move requires a decimal point, right? It's not the case that 20 is the same as 2. 2.0, however, is the same as 2. We see that 5 goes into 20 4 times. 4 times 5 is 20, so nothing is left over. 2 divided by 5 is the decimal 0.4. All right, for 5, it doesn't really matter which method we pick. They're both pretty easy. Let's see a different example. Let's suppose we wanted to write 17/8 as a decimal. Well, we could look at the prime factors of 8 and see that 8 has more 2's than 5's among its prime factors. So we know we're going to need to multiply by 5, but I think we're going to need to multiply by 5 several times. Perhaps this method will be easier. We'll understand 17/8 to mean 17 divided by 8. 8 is the divisor, it's the denominator, so when we write the division bracket, 8 will go outside, 17 point will go inside. 8 goes into 1 not at all. It goes into 17 twice, as 2 times 8 is 16. 17 minus 16 is 1. And now we'll bring in a 0 to the right of the decimal point. 8 goes into 10 once, as 1 times 8 is 8, with 2 left. There's still something left, so I need another 0. 8 goes into 20 twice, as 2 times 8 is 16. 20 minus 16, that's 4. I need yet another 0. 8 goes into 40 5 times. 5 times 8 is exactly 40. There's nothing left, so I stop. Decimal point, I notice, goes up here. So I'll have 2.125. So again, what are the key points here? It's vitally important that we write in the decimal point before we start adding zeros. And it's important that we remember that the denominator is the divisor. Every time in our entire life ever, the denominator is the divisor. That is, it goes outside the division bracket. All right, I'm going to give you one of these to try. Write 37/40ths as a decimal, specifically by using decimal division, so by using this new method. Pause the video and try this now. All right, so we're going to understand our 37/40ths as 37 divided by 40. So we're going to write 40 goes into 37 point. 40 goes into 3, not at all. Into 37, not at all. So we'll add a 0 to the right of the decimal point. 40 goes into 370, I think 9 times, since 40 times 9, well, 4 times 9 is 36. And then I have a 0 on the end. Yes. 40 goes into 370 9 times. 9 times 40 is 360. Subtracting, I get 10. There's still something left, so I need a 0. I think 40 will go into 100 twice, since 40 times 2, well, 4 times 2 is 8, and then I have a 0 on the end. Yes. 2 times 40, that's 80. Subtract again, and I get 20. Another 0 on the end. 40 goes into 200, I think 5 times, since 4 times 5 is 20, and then a 0 on the end. And now nothing is left. 37/40ths is 0.925.